This is too many ingredients. We've already seen that we don't really need baking powder. What else here is redundant? In other words, what are the minimal ingredients I need to make cookies? There are methods to convert the all-purpose flour to other types. Brown sugar can be made from a combination of white sugar and molasses, so we can remove that. And eventually we'll be left with 9 ingredients. Each of these is important and can't be replicated by any of the others. That makes this a basis of cookies. The dimension of cookies is 9, which is the number of vectors in the basis. Notice we started with many more ingredients in our set, but only 9 were important. So we say the rank of these is 9. For matrices, the rank of a matrix is the dimension of the column space, or the number of pivots. The dimension of the null space is the number of non-important ingredients. In a matrix, it's the number of free variables. Notice the rank plus the dimension of the null space is the total number of ingredients on the counter. This is called the rank theorem. For any m by n matrix A, the rank of A plus the dimension of the null space is n, or the number of columns. In other words, the number of pivots plus the number of free variables is the number of columns. This should make intuitive sense to you based on your experience solving systems of equations. The basis theorem says let H be a k-dimensional subspace of Rn. Then 1. Any linearly independent subset of H with exactly k vectors is a basis of H, and 2. Any k vectors that span H are a basis of H. This is a very useful theorem. It links linear independence, span, and dimension together. Remember, a basis is a set that is linearly independent and spans. The number of vectors in a basis is the dimension. And you know what we really need? More conditions for a matrix to be invertible. This is going to extend the list we had before. Each one of these should make you say, oh, yeah, of course. If they don't, well, you know what you need to review.